rational functions. Okay. So rational functions are of the form something when we have a variable in the numerator and variable in the denominator, right? These type of functions we can call that rational functions. And if we have the variable only in denominator, something like k upon x, something like this, then we call these type of functions what? Reciprocal.
Acha. Why? Like, why reciprocal? Like k upon x as in f, but okay, f k.
Yeah, k is a constant here.
Okay, okay.
As x is a variable. So these functions, when we have a reciprocal functions, like I can also write a form of reciprocal function such as something k upon, let's say ax plus b. I can write like this also. So basically any constant divided by linear, so linear or quadratic or anything in the denominator. I can also write fx is equal to k upon x square. So these functions which I have written here, they are all reciprocal functions. And generally they have x-axis and y-axis are asymptotes when it is like k upon x or k upon x square. K upon x square is something like this form, right? This is k upon x square.
K upon x square, and the previous one is k upon ax.
K upon x.
Previous one, this one, the one to the left. Okay, k
Right.
upon x. Okay.
Right. But if I have like something, for example, let me write let's say 2 upon let's say 2x minus 6, for example. Okay.
Okay.
Something like this. So this is what? Reciprocal or rational?
So this would be reciprocal, right?
Reciprocal, of course. So in the first one, we have asymptote x-axis, which is y is equal to 0, and y-axis, which is x, right? Over here also we have x axis asymptote, for the right, for the second one. So y is equal to 0, and then we have another asymptote, which is x, which is y-axis. So what should be the asymptote here for this function? You tell me.
Sorry, so could you repeat, sir?
What should be the asymptote here for this function? Fx is equal to 2 upon 2x minus 6. What should be the asymptote?
Which one, sir? Which asymptote? Vertical or
asymptote?
vertical?
Okay, tell me both the asymptotes. Reciprocal functions always have two asymptotes. One is horizontal and one is vertical.
So for the vertical, okay, so for the vertical asymptote, it's going to be which one, sir? Minus 3 by 2 is going to be, so 3 by 2 is going to be so 3 by 2 is going to be vertical, right?
6 by 2.
Sorry, 3 by 1, 3 basically.
So over here, look at this. Horizontal asymptote is only the x-axis, which is y is equal to 0.
Yeah.
Because y cannot be 0, because this figure, whenever we have a variable in the denominator and there's no variable in the numerator, then we cannot get y 0 for any value of x. That's why horizontal asymptote is horizontal asymptote is what? Always y is equal to 0, because that is not going to be possible. So it's not a part of range. And vertical asymptote is what? When we put denominator equal to 0.
Yeah.
So 2x minus 6 equal to 0 we are putting.
So 3.
X is equal to 3. That's a vertical asymptote. No, because this is not going to be part of domain, right? So if I'm writing, for example, if I'm writing domain for this function, then domain is what? X says that x belongs to R, comma, x is not equal to 3, right? That's the domain. And what would be the range? Y says that y belongs to R and y is not going to be 0. right? Y is not. That is the range. Okay, now let's draw this function. So for drawing, first of all, I'm drawing the x-axis and y-axis. And then I'm drawing the asymptotes. So x-axis is asymptote for horizontal and for vertical y is equal to 3. Sorry, x is equal to 3 for the vertical. So x is equal to 3, I'm just making a line. That's at 3. And now, like how to draw it. So you see, let's say if you are putting like 4, 5, 6, any value. Let's say, for example, I'm putting x equal to 5. Then what I'm getting, y is equal to 2 upon 10 minus 6, 4, which is 1 upon 2, right? So if I'm putting like say 5, so I'm getting here 2, somewhere like this, So you can get an idea, or you can get an idea like what is the y-intercept here, So y-intercept, if you want to find, so you can put x0. And you see y is equal to 2 upon minus 6 and minus 1 upon 3. So that is going to be negative here, here, like something here. So
Yeah.
the curve is something going to be like this, like this. Right? And over here, it is something like
Yes, yeah.
So yeah, it's going to touch the x-axis. It's coming close to the x-axis, but it will never touch the x-axis.
Yeah, of course.
Right? Right. So this is a graph of
so 1 by 2 and minus 1 by 3 signify what?
Sorry?
Values of y. 1 by 2 and minus 1 by 3 signify what? Values of y.
Minus 1 by 3. Minus 1 by 3 is a y-intercept.
Y-intercept and 1 by 2?
1 by 2, like I was just putting some value for x. I mean, like, a bigger value than 3, just to get a point. So, so we can make a little bit accurate graph.
Well,
Let's say sometimes we show like 2, 3 points. So this point is something 5, 0.5, This point we have shown, and we have shown this point here, And so we can show like x tends to infinity, then y tends to 0. And here I can say x tends to 3, y tends to infinity, isn't it?
Yeah.
Similarly, x tends to 3. Or I can say the 3 plus, here I can say 3 minus, y tends to minus negative infinity, x tends to infinity, y tends to 0 minus 0 plus, right? So that was a reciprocal function, okay? These are all our reciprocal function which we have discussed. These 3 functions we have discussed, and these are reciprocal functions. Okay. Now let's come to this one. Yeah, actually, I didn't so simplified it, in this. I mean, like, if I'm going to simplify, then it can be x minus 3, right?
So x minus 3.
X minus
because
3,
you've
right?
taken 2 as common.
Yeah, but it's the same thing.
Yeah,
right?
pretty
It's
much
the
the
same
same
thing.
thing.
It's the same thing.
Yeah.
So now let's come to the rational functions. So rational functions, when we have a variable in the numerator and denominator, variable is in the numerator and denominator. Okay. So over here we have linear in the numerator and denominator, and linear in the denominator. So so this one thing you have to see that sometime we write a function in the form p plus q upon gx. This is so this function which I have written right now. Look at this function. This function is what? Reciprocal function or rational function? What you can say?
So this one would be p plus
gx.
q
Let
by
me say gx is something cx plus d. Let's say gx is gx plus d means gx has a value.
I think it should be reciprocal again.
Okay. Uh, this function is reciprocal. as
Yeah.
well as rational.
As well as rest. Okay.
Right, it's some point to be noted down, basically. See what happened. I'm just connecting both the functions, okay?
Yeah.
So what happened, let's say I'm writing a function fx is equal to 2 plus 5 upon x minus 1. That's it. All right.
Yeah.
So see, in the numerator, there is no variable, right? And how this function is formed, if we see the transformation of this function, then we have a function f1 upon x, right? Which is actually transformed horizontally.
Yes, sir.
Then it is transformed, then it is got stretched by vertical stretch by a scale factor of 5. And after that, it has got translation,
What is it? Translation
vertical
by
translation,
2.
vertical translation.
Vertical by 2, right? Vertical
by 2, yes, by 2.
So
Right.
so the 2 makes it rational, but the 5 by x minus 1 makes it reciprocal.
Yeah, so a reciprocal function finally, after basically stretch doesn't play that much big role. I mean, like if you are just doing the translation, for example, if you're translating by 1 and 2, let's say, let's say, then it become what? X minus 1
Minus
plus 2
1
plus 2,
plus 2.
right?
Yeah.
And if you are solving it, I mean, then how? Let's say you're solving it, so you can write 2x minus 1 upon x minus 1, isn't it?
Yeah.
So 1 plus 2x minus 1 upon x minus 1, right? And that gives you 1 plus 2x minus 2 upon x minus 1. And this is 2x minus 1 upon x minus 1, right? See? So see what I'm writing here now. 1 upon x minus 1 plus 2 can be written as 2x minus 1 upon x minus 1, right? Right? So
Right.
look at the left side is what? Reciprocal form. Reciprocal. And right hand is, you see, what is that? Rational.
Rational.
So whenever a reciprocal is translated vertically, it becomes rational. Is that clear to you?
It's slightly like thoda sa off, वो है. I'm also a bit preoccupied. मेरे mind में बस.
Let's say, see, 1 upon x, let's say, it's a pure reciprocal function, isn't it?
Yeah, pure reciprocal.
Okay. If I'm writing, let's say, plus 2 only,
ये हो जाएगा.
Now
This
what?
will be reciprocal and rational.
Yeah, 1 plus 2x upon x, isn't it?
Yeah.
So see,
Now
I've
1
just
plus 2x
translated
upon x, so 1 plus 2x upon x. You could take, okay. So
1 plus 1 upon x plus 2x upon x, isn't it? So I can write 1 plus 2x upon x.
so it can be written in reciprocal form or rational form, either.
Yeah, So just I have translated vertically, then reciprocal become what? Rational.
Oh.
Right. Only a vertical translation made a reciprocal function to rational. Because we have got a variable in the numerator also. Right. So this is also, so that's why we say, like I was trying to connect it before, like if we have a function, any reciprocal function is added with any number, like say, look at this form, the one which I've written earlier, this form. Look at this one, So that's a P is a constant, and Q is also a constant. And Gx is a function, maybe linear, maybe quadratic, whatever, So whenever we have this form, so what is this? Is basically reciprocal as well as rational form.
Rational. Got it.
All right. Okay. Cool. So
Okay,
now in these forms, wait, in these forms, just one quick thing. Let's say if I have P plus Q upon Gx, So we have again two asymptotes. So one is horizontal asymptote and one is vertical asymptote. And horizontal asymptote is what? Here, y is equal to P, that constant. And horizontal asymptote we get by putting Gx is equal to 0 and we solve it. Solve for x. Right? That's how we get the vertical. for just for one example, I'm taking quickly. Fx is equal to, let's say, 2 plus 5 upon x minus 1. Okay. So here, my horizontal asymptote is y is equal to 2, and my vertical asymptote is x is equal to 1. And graph will be something like y is equal to 2. So it's a vertical line here.
Then
That 2. And then x is equal to 1. So I
x
have
would be 1.
one line here. And let's see the y-intercept, because you never know this is going to be like this, or maybe like this,
Yeah.
So let's see, when we are putting x equal to 0, then y is equal to 2 plus 5
So
upon
minus
9.
3 हो जाएगा.
So minus 3, right? So minus 3, so that means y-intercept is minus 3 is somewhere here, right? So it is something like this now. Right, and obviously this line is something like this.
And so x-intercept, like x-intercept ऐसे हो जाएगा.
X-intercept, yeah, you can put y0 and you can get it,
Exactly.
right?
ये तो हो जाएगा आराम
Like in case you need to show it or you need to find
No,
it, you
no,
can find
yeah.
it.
So y equals to 0 करके हो जाएगा आराम से.
Correct. X is equal to 1, and this y is equal to 2.
That's right. Understood.
All right.
All right.